Okay, guys, you got me. You got me. I don't want to do maths. I really don't. But I just went on Instagram. Oh my lord. This girl I absolutely loved in my economics class. I followed her. I don't even. That's what I hate about public following. Because if you follow a public account, yeah. If you follow the public account and then they don't follow you back, you've ain't got to search up and unfollow them. But if you follow a private account, this is how it should be. They either don't accept you, you forget about them, or they accept you and then they follow you back. If you have a private account and you accept someone and then don't follow them back, you're a gimp. You are a gimp. Oh, for flip's sake, bro. I don't want to show that. I don't want to show this finger going up your ass. Why is there a woman's hair in my bedroom? We know no one was in here. Okay. Y equals AKX. Flipping out, bruv. What question that one, mate? It's a reflection of y-axis, but it's from the right to left, because the one where it's negative x is left to right. A geometric sequence was I forgot what it was. A multiplied by r to n take away 1. But if it was r was less than 1, so essentially just if r was a decimal, wait, that's cos 2a. Okay, so you'll put that into the form 5x negative 4 per half. And you would do So you multiply by the function. You multiply, I don't even know. Multiply by the power, take one away from the power, and multiply. Motherfucker, you didn't have to do the U thing. You just could have kept it how it is. Oh damn, I never finished watching that video. What I'm gonna do... Right, let's see if... Bro, is it me or everything just looks better? Anyway... Bro, I don't understand, bro. I don't want this. Classify. Right, it's something I really thought that would work. But someone actually tell me why my YouTube's not working. Okay. We're actually going to ignore that I just opened that. Well, that was open. We're just going to pretend that wasn't open. Okay, so we're just going to do these two. We're just going to do the very last questions.
Differentiate x1. We get y plus 5. X minus gradient.
Okay, the curve has the equation y equals ln 2x plus 5 of the tangent. Okay, so we just want dy over dx is equal 1 over x. It's literally just equal 1 over x. It's that simple. Because ln 2x goes to ln 2 plus ln x. Yeah. And then when x equals 1, gradient equals 1. When x equals 1, y equals ln 2 plus 5. So y take away ln 2 plus 5 equals 1 over x take away 1. X take away 1 equals x take away 1 plus ln 2 take away 5. Y equals that, surely.
We x log minus times x minus.
Oh, that was literally it. Okay.
So when x
that was
is
pretty easy then. Let's just
the chain rule says y is going to give us 1 over y plus 1.
I mean, if these are the last ones, I'm just going to do this one. Okay. X is equal to ln y plus y3 dy dx. So we're going to do dx dy here. We get 1 over y plus 3y squared. And then dy over dx is equal y plus 1 over 3y squared. B x equals 2 sine y dx over dy just equals 2 cos y.
1 over 2 cos y.
Okay. So we pretty much actually got those locked down. We just got the parent rule, boom. Okay. We have all those rules. I'm gonna go over shit. And then I'm also going to accept that person on Instagram. Because I cannot be seen trying to make them.
when we have something in the form
I got a Maths Genie book that has all my shit in it. It's like, that's the full one. We can get rid of that. That's my full book. Okay, this is my Maths Genie book. Why she message me then ignore me?
y equals uv, so two things multiplied together. So we have a u and a v. When we've got two things multiplied together, we can differentiate using the product rule. And the product rule says that dy dx is u times dv dx plus v times du dx. So we're going to differentiate both of these.
Du dx u is equal to
These and then put them into our formula. So we're going to substitute them into here, and that will be our dy dx. So starting with u, we're going to say u is x squared. So that means du dx is 2x. We're going to say v is 1 plus 4x cubed. So dv dx, using the chain rule, so times by the power, take one off the power, and times by the bracket differentiate. So dv dx is 12 times 1 plus 4x squared. So we've got u, du dx, v, and dv dx. So we can say that dy dx is u times dv dx So x squared times 12 times 1 plus 4x squared plus v times du dx. So that's 2x times 1 plus 4x cubed. Another question. So again, we have u and v. So 2 two things multiplied together. So for u, we're going to say it's x minus 2. So du dx is 1. We'll say v is 2 minus x to the power of negative 2. So dv dx is going to be times by the power, so negative 2. Take 1 off the power, so negative 3. And then times by the bracket differentiated, which is negative 1. So it's going to become positive. So we've got u, du dx, v, and dv dx. We just put them into our formula. So dy dx is u times dv dx. X minus 2 times 2 times 2 minus x to the power of negative 3 plus v times du dx, which is 1 times 2 minus x to the power of negative 2. And 2 times v, and that means dv dx is so it's 6 to our u times u squared. U
Yeah, we're just gonna do this on a whiteboard. There's no point in just using all that paper. Like, chat, I'm gonna be real. So y equals x squared v equals 5x negative 3 to the power of 4. So dv over dx is equal to 4. 5x negative 3 to the power of 3 multiplied by 5, making that 20. So so we've got x squared multiplied by 20, 5x negative 3 cubed plus 5x negative 3 multiplied by 2x.
V to the power of 4. Some more questions. Again, we can see we've got two.
Okay. So we got y is equal to e to the power of x, 2x negative 3 to the power of 3. So e to the x equals u. Du over dx equals x multiplied by ex. V is equal to 2x negative 3 to the power of 3. So dv over dx is equal to
Two things may be 3 negative 1. We've got 2 is e to the power of e.
what? I suppose the whole point of an exponential is that you multiply it.
X times 2.
Okay. I just realised I actually accidentally wrote the right answer.
2x of x times 2x minus 3 cubed.
Where the fuck have I got cos 3x from?
X is to give cos x. So dy dx times 3x plus 2 cos 2x cos 3x.
Okay. So we've done the product rule. But what I like about English, I can learn the formulas and that using this thing. And then I can actually apply it later. Okay, this will be year 2 rotation. The product rule. When y equals uv, dy over dx is equal to u multiplied by dv over dx plus dv plus v equals. Sorry, let me restart. When y equals uv, dy over dx is equal to u multiplied by dv over dx plus v multiplied by du over dx. Why did you say skibbity toilet? I say only no items. What's actually wrong with me? Why did I actually ever sing that song? And the fact that's in multiple people's phone makes me quite sad. I mean, I'm assuming, yeah, we're not even at the hour mark, so we could maybe go through all of differentiation like an hour. I don't know if that will be.
If our function is in the form y equals u divided by v, so something divided by something else, we can differentiate using the quotient rule.
Okay.
And the quotient rule says that dy dx is v times du dx minus u times dv dx all over v squared. So if we've got a function divided by a function, we're using the quotient rule, and it's v du dx minus u dv dx over v squared. So in our first question here, y equals x squared over 2x plus 3. So we can say that
Wait, do I have to memorize these? Is this not in the formula book? Bruh. Who's messaged me? What time are you working there?
U is x squared. That's the one.
I forgot. Helen set a flipping mass paper as well, bro. I don't want to do that. Oh, that's a lot. That's a lot nicer.
On the top U is, which is 2x times 2x plus 3 minus U times dv dx, which is 2x squared, and that's all over v squared.
I'm so confused. What?
E times du dx, which is
V times du dx.
two x times 2x plus 3 minus u times dv dx, which is 2x squared, and that's all over v squared, which is 2x plus 3 squared. We can simplify this. So if we expand the bracket, we get 4x squared plus 6x. So 4x squared take away 2x squared is 2x squared. So we've got 2x squareds plus 6x's over 2x plus 3 squared. And we'll leave it like that. For part B, again, the top one is u.
It's the same thing. I mean, they're all the same thing. So I'm just now going to do it solo. So I'm going to get y is equal 4x plus 3x negative 1 squared. This can be used as u over v, where dy over dx is equal to u multiplied by dv over dx, take away v, multiply du over dx over v squared. Nope. It's v squared. First. If I can actually see what he's fucking about.
So u is 5. Leave it like that. For part B, again, the top one is u. So u is 1 minus 1 weighted. That's the chain rule. 2 for u over 3. Through by 3x minus 1. $12 minus. And another set of questions.
Like, these are pretty much, you just gotta learn the rule and then move on. You just gotta learn the rule and then be able to apply it to harder things, and then you can just call it a day. So his ones actually look harder. So I'm gonna do his. Y is equal to e to the power 2x over cos 2x. Okay, so u equals du over dx equals 2 to the 2x. V equals cos squared x. So I've actually done that wrong. So dv over dx is equal to I don't actually know how I would do that. So I would just write that as cos times cos x. If I were to differentiate that to negative sine x. Let me see.
Logs x times the bracket differentiated, which is negative sine x. Substitute them in.
How the fuck has he got that?
Cos x sine x. So it's negative 2 sine x cos x. Substitute them in.
How has he gotten that?
Is 2 cos x times the...
I see what he's done here. What a little gimp. So we got cos x squared.
bracket differentiate them.
Okay, but see, that's not knowing the quotient rule. That was not knowing that. Now we want to keep the v's on one side. So you do cos x over cos x squared, which is cos x to the power of 4, multiplied by du over dx, take away
So dy dx sine x cos x over v squared. So cos to the power of 4 cos x this time. Cos x plus 2e 2x
I suppose you can simplify it.
sine x q 2x u.
Personally, I would have never bothered. We're going to do this start to finish now. So, we need to learn to stop doing that. So,
is log x. Well, take 1 off the power times x minus 1. Then dy dx minus u dv dx 4 log x times 2x minus 1 over v squared. And then let's get rid of the fraction by term by x for x log x minus 1 cubed. And I'll leave it 2 for you to try. See if you can give them a go.
See, the quotient was actually pretty. I don't know. I kind of find that cool. I find that cool. What is a product? Okay. I have to have a whiteboard. I actually have to be able to whiteboard it out. So I'm gonna do. The product rule is when y equals uv, dy over dx is equal to v du over dx plus u dv over dx. I was right. I'm just going to put that as right because I did do it.
In this video, we are differentiating some more trigonometric functions.
Actually, what's the time? I'm going to take a mini break. By a mini break. Debenhams? Are you kidding me? They actually did it for 16 quid. Oh, that was just a lie then. Club de Moët. Yeah, bro, it doesn't smell muscular. Oh, to be fair, I mean, it has all of them, really. It has all of them. Bro, I thought they were the same thing, bro.
This section here has been cut out of the formula book. we can see that when we differentiate tan x, we get sec squared x. Sec x differentiates to give sec x tan x. Cot x, negative cosec squared x. And cosec x, negative cosec x cot x. And we can see all the k's in here, which is a version of the chain rule. So tan kx, we times by the bracket differentiated, which is k. So it differentiates to give k sec squared kx. All of these can be derived using the quotient rule. So if we change tan x into sine x over cos x, use the quotient rule, we can see how we get sec squared x. I'm not going to do that now. I'm just going to be using them as they're given to us in the formula book. So the first question, y equals tan 2x. So tan 2x, we can see from the formula book, dy dx is going to be 2 sec squared 2x. Second one, we've got x.
Well, that would just be 1, no?
Cot 5x. We've got two things multiplied together. So it's in the form uv. It's the product rule. So u is x, du dx is 1. V is cot 5x. And we can see that cot kx differentiates to give negative k cosec squared kx. So minus 5 cosec squared 5x. And the product rule, dy dx is u dv dx plus v du dx plus or 5x cosec squared 5x. And cosec squared x, so we're going to use the chain rule for this one. That's the same as cosec x squared. So we times by the power, take one off the power, and times by the bracket differentiated. So it's going to be 2 cosec x times the bracket differentiated, which is negative cosec x cot x. So we have negative, what, 3.
Okay, let me now just work through all of them. Okay, so if y equals cosec 3x
x cot. So dy dx. So dy dx 2 tan x. More questions.
Yeah, I mean, if I could just do these, I'll be happy. So we got. Bro, I mean, do I really want to write it? I mean,
So set is 5x. So dv dx is v du dx minus u dv dx, which is 5 cot 2x, over v squared, which is 5x times 5x, so 25x. So
I'm gonna simplify this next one as much as I can. So we've got f of x equals ln x. This is a product rule, so u equals ln x du over dx equals 1 over x. V equals tan x dv I don't think
u is
simplifies.
x 2 arc sine or
What the fuck's with arc sine?
arc cos x. So arc sine x means the shift sign. So y equals the sine minus 1 2x. So shift sign is arc sine. So to differentiate this, we want to get rid of the arc sign. The opposite, we can see that sine equals sine
thought you just put it to the power of 1 and did a
is arc sine. So to differentiate this, we want to get rid of the arc sign. The opposite of arc sine is sine. So sine both sides, we get sine y equals 2x. So we can see that sine y equals 2x, which means y equals arc sine, shift sine, 2x. And then we're going to get x by itself by halving both sides. So half of sine y equals x. So we can do dx dy, where we do y when it's x equals y, dy is dy more plus sine squared y equals 1. So if I want cos y by itself,
wait, where does this come from? You got your answer, G.
identity, cos, so that is dy dx. But if we want to give our answer in terms of x, we can do even more.
In terms of x. Why would you do that, mate? Why would you do that?
We can use the identity cos squared y plus sine squared y equals 1. So if I want cos y by itself, cos squared y is 1 minus sine squared y, and cos y is equal to the square root of 1 minus sine squared y. So I'm going to change cos y into the square root. So dy dx is 2 over the square root of 1 minus sine squared y. Then I'm going to change sine y into 2x. If sine y is 2x, sine squared y is 2x times 2x, so 4x squared. So I'm going to give my final answer as 2 over the square root of 1 minus 2x times 2x, which is 4x squared.
Flipping out, mate. This is just y is equal to cos negative 1x divided by cos y equals x. Dx over dy is equal to negative sine y. So dy over dx is equal to 1 negative sine y. But we want it in terms of x, sine y. So we got sine y squared plus cos y squared equals 1. We get 1 take away cos squared y is sine squared y. Sine equals square root 1 take away cos squared y. So you got 1 over square root 1 take away cos squared y. Take away equals dy dx. Bro, my numpty. Cos squared x. I swear that's literally it. Like, it doesn't even take that long. Like,
Cos y is x.
I don't understand why you can't leave it in cos x. Alright, please tell me this shit's over by now. I've got half an hour longer. Shit's not even that hard, really. I mean, to be fair, actually, I don't like it. It turns my colour fill off every time. I just smell so good. I literally sprayed this on my arm yesterday. I want to look at the homework. Okay, so it only goes up to the quotient rule. Oh, let me look at my maths book. Wait, there's no way I've actually filled out all of these. Yeah, I'm gonna throw them all out in a minute because I don't actually need to know this stuff. Yeah, he said 9A. I was like, they can't know it at that ahead. But yeah, if I now go back onto Maths Genie, yo, I actually enjoy doing maths in the morning. I might even finish differentiation. Well, I say I might. I most likely am going to. No, I've only got half an hour left. But the quotient rule, that's that. Oh my god.
When we have parametric equations, we can find dy dx by doing dy dt divided by dx dt. And we can see that this works using the rules for fractions. So if we had dy dt divided by dx dt, dy dt, that's the same as dy dt times dt dx. And then the dt's cancel out, and it leaves us dy dx. So dy dt divided by dx dt gives dy dx. So this question says find the gradient at the point where t equals pi over 4.
I'm a bit confused then. What's the point in doing that? Surely you could just write dy dt then. multiplied by dt over dx. No. Wait, let me do that. Let me do that instead. I want to see how that goes. So. That's what again. Why not just do dy over dt equals dt over dx? That's what I'm confused about. Why not just do that? What rule even is that as well? I actually forgot what rule you use that for. But yeah, that's just the chain rule. No, it's not. I don't know what it is. Yeah, if we just do dy over dt equals dt over dx, surely then dy over dt. Okay, so if y equals 2 cos t, dy over dt is equal to negative sine t, and if x is equal to 3 sine t, dx over dt is equal to cos t3, dt over dx over dx is equal to 1 over cos t, and dt over dx multiplied by that, this is negative 2 sine t over cos t, which would be negative 2 tan t.
Divided we to which is to.
Okay, I was entirely fucking wrong. What did I do, bro? Yeah, I don't know why I forgot the 3. Negative 2 over 3.
T. Change type tan. Try. See if you can give it a go.
Yeah, there's no point in doing that whole division thing, bro. There's no point in doing the division thing. It's just literally the same thing where t equals 2. So we just want x equals t squared plus 5t. So dx over dt is equal to 2t plus 5. Y is equal to 5t. So dy over dt is equal to 5. So wait, we can flip any of them actually. Next, we want dy over dx. So then we flip this to 1 over 2t plus 5 dt over dx. Got 2 over 7.
This
Why do I feel like
it's 2 dx 5/9.
Bro, my brain is going.
Equations.
This is actually really easy. I think I've already got that. Oh, that's the final question as well. So x is equal to 2t squared. Y is equal to t squared taken squared. Find the equation of the tangent. So we want dx over dt. Wait, what did I do wrong? Oh, it was 2t cubed.
Find the equation. We don't have to. I'll leave it as it is.
Wait, what? But where has he got 1 over 3 from? Oh yeah, okay, I see where he got it from. That was just me being a little silly goose. Yeah, this. Yeah, so this didn't even this doesn't even deserve. Yeah. No, it don't deserve me actually looking into it. We got implicit difference. So we're actually nearly done then. We said we are meant to finish it by January. Oh, so he's actually done A-level stats. He just hasn't done AS stats, which I don't know. What's OBS saying on the time? Okay, shit.
When an equation is given implicitly, that means the y's and the x's are mixed up together. So it's not in the form y equals. there's a function with x's and y's in it. And we can differentiate implicit functions. We can differentiate implicitly using the chain rule. So whenever we differentiate y with respect to x, we differentiate y becomes dy dx.
How would I book holiday?
So we can differentiate using the chain rule. Y differentiates to give dy dx.
Thank you. If I work, I can book 3 weeks off.
So let's look at the first question. Find dy dx in terms of x and y. So we've got x squared, which differentiates with respect to x to give 2x.
Yeah.
And then 3y cubed, we're using the chain rule. So the y is like a bracket, times by the power, take one off the power, and then multiply by the bracket differentiated.
Okay.
So 3 3s are 9, take one off the power, goes to 2, and then times the bracket differentiated, which is dy dx. So whenever we're differentiating a y, we differentiate it normally and just write dy dx after it. 5x differentiates to give 5, and the 5
in the chain rule, you would then do
has no gradient. That's 0. So we want dy dx in terms of x and y. So we want dy dx to be the subject. So take 2x away from both sides, take 5 away from both sides, and divide by 9y squared. So that is our dy dx. Another one.
so that kind of makes sense.
This time we've got a product rule within the question. So we've got 2x cubed, differentiate it normally, times by the power, take one off the power, that's 6x squared. Now 5xy squared is a product rule. It's in the form uv, two things multiplied together. So we're going to say u is 5x, v is y squared, which means du dx is 5, and dv dx, so differentiate it normally, 2y, but then multiplied by dy dx, so 2y dy dx.
Why are we doing that? Is it because when you put the brackets around that y, when you put the brackets around the y, so you get 4y, y squared, we do the bracket different. So times by 2.
So 5xy squared differentiates to give these two multiplied together, so 5y squared, plus these two multiplied together, 10xy dy dx. And we've got 4y, so differentiate it normally, which would just be 4, but then times by dy dx.
Why are we doing that? Why
So
are we doing that?
4 dy
I
dx,
understand.
and that equal,
You did the bracket, right? If you did the bracket, 4y, y in bracket, multiplied by the power, which is 0. So that would actually just give you fuck all. That would actually just give you nothing.
X differentiated, which is 1. Again, we want dy dx.
Actually, wait, no. 4y.
Dx to be the subject, and this time it's in 2 terms. It's in both of these. We're going to dx. Okay.
Bro, is it me or is this maths just super easy in the morning? Like, this wasn't hard at all. I feel like I could do this for hours.
So find dy dx.
Well, please just tell me I'm up with the time so I can continue this later. I'm not. Well, I mean, I'm just going to do the questions anyway. I feel like I can actually just blast through them. So we got 4x squared plus 5y squared negative 3y plus x equals 5, right? So dy dx dy dx dy dx. Okay. So the x is normal. This would be just 8x plus 10y. That's the thing. I want to leave this y normal, but I feel like that's illegal now.
In terms of which is factorize dy dx out of 2 terms and move everything over to the other side. So dy negative 8x. It might be nicer if we multiply top and bottom by -1. So we don't have these negatives, but I'll leave it like.
I actually bossed that, so shit, that's the wrong colour pen.
that for now.
Okay, what's the time on the clock? Okay, we're just going to do this next question. And then, yeah. And I'm gonna eat some food, watch some soup, have a bath, etc. Okay. So we have 2x cubed plus 3x cubed y 2x squared equals x plus y. Are we even going to bother getting it on the same side? No, I can't be bothered. So if we dy over dx that, we get 8x squared plus 6x. Oh, no, we have a product rule. Yippee. Okay, so we have 3x squared. Wait. Because dv over dy is just going to equal to 1, right? So it's just going to be. That's
Part B, x y squared from these two times together equal.
Damn, did I do something completely wrong? I'm so confused. Why is dv? Why is? Oh no, because it's dv with dx. It's not. It's dy. What the fuck's happened?
Now, we've got 3x squared. So du dx is 6x. V is y. So dv dx is dy dx. So
That's not how the product rule goes, though.
Differentiating now, we've got 6x squared plus these two times together, 3x squared dy dx.
Okay. We'll continue with this another day.